Okay, final video. Question 10. Find the total area of the shaded region. So just remember we're on continuous distributions. The total area under this curve is 1. We want the area of the shaded region. It's got to be between 0 and 1. And it looks like it's a little more than a half. So that's an idea you already know, right? So we do our distribution. When you have a standard normal curve, your mean is 0, 0's in the middle, and your standard deviation is 1. So that means if you go 1 standard deviation over in any direction, right, they're about the same. Now if you remember, 1 standard deviation in each direction, exactly 1 standard deviation, has about 68% from your empirical rule. Well, this is a little less on this side and a little less on this side. So we're definitely less than 68%, but we're more than half. So that gives us an idea. All right, so probability that your z is between negative 0.9 and positive 0.8. This is your lower limit. This is your upper limit. Here's my mean. And here's my standard deviation. So we're doing a normal distribution. Okay, here we get, just like we expected, 0.604, more than half, less than 68%. Okay, question 11. Probability that z is greater than or equal because it's to the right. Remember, this looks like more than half. So we should get a number bigger than half. Looks almost like 2/3. So let's see how close we are. So we're going to do our normal distribution. Our lower limit is negative 0.788, and our upper limit is infinity. When you do this on a calculator, you're using a normal CDF with a range or normal range. So your lower is your negative 0.788. Generally, you need an upper. TI wants an upper, so just do something like 1 with 99 zeros. That's 1E99. Okay, that's not too bad. All right, we said it was close to 2/3. It's bigger than that. It's 0.7846. Oh, that rounds to 47. Perfect. Okay. Number 12. Now the whole area is 1. So if I want to find these shaded regions, I can add them up, or I can do 1 minus the excluded region. All right, so 1 minus our normal distribution. And we get 0.419. That rounds to a 6. All right, number 13. The amount of water that each American uses each day averages 105 gallons. The standard deviation is estimated to be 25 gallons. What is the probability that a randomly selected, so that's the probability X, is less than 90? So you can convert to a z-score, or you can use your normal distribution function. Your lower limit is negative infinity, and your upper limit is 90 for x, or whatever your z-score is. All right, if you calculate your z-score, by the way, it would be 90 minus 105 over 25. Negative 15 over 25, right? That's negative 3/5, negative 0.6. So just to give you an idea, if you put 0 in the middle, you want the area from negative 0.6 to the left. If you're actually talking about water, same curve, you just put 105 and 90 here. But this area and this area are the same. This one has been standardized, and this is in terms of x. Standardized means you're in terms of z, right? When I run that distribution, I get 0.2743. Find the z-score for someone who uses only 80. 80 minus 105 over 25 is negative 25 over 25, or negative 1. If you have a z-score, you can also work backwards to find x. First, you're going to want to multiply by 25 on both sides of your equation. That will clear out your fraction. So I'm going to multiply both sides by 25. So my next line will say negative 38.5 equals x minus 90. Add 90 to both sides of your equation, and you end up with, oh, sorry, that should say 105. You should end up with 66.5 as your x. Good thing I caught that. All right, what proportion of people use less? Now, a proportion and a probability and an area all go hand in hand. So we're still talking about, here's 105 in the middle and 130 way off to the right. What proportion use less than 130? So that's the same as the probability that a random person uses less than 130. We don't need to worry about the or equal to, because this is a continuous distribution. Okay, and we get 0.8413. Number 13E. If 500 people are surveyed, how many of them will use? Now, we're still going to find a proportion. So it's 500 people times the probability x is greater than 115, because this is not just a probability, right? This represents a proportion. So we say 500 times, we find that proportion. The lower limit's 115, the upper limit is positive infinity. We get, now remember, this is people, so even though my calculator tells me 172.289, well, that means I either have 172 or 173 people. Now this is just a model, so both of those are going to be fine. 14, find the area under the standard curve that falls to the right of negative 1.98. So way over here to the right, the probability that C is greater than negative 1.98. So negative 1.98 is my lower limit. My mean is 0. How do I know that? This is standardized. All right, we should get about everything, or 0.9761. That's a lot. In 1976, Brits drank an average of 64 grams of tea per week with a standard deviation of 20. So I've got a mean, I've got a standard deviation, right? Find the probability that they drink between 38 and 98 grams of tea. Now, one thing's missing. We don't know that this is a normal distribution. So first, let's write this. Assume tea drinking is normally distributed. Well, of course, we have to know what type of distribution we have in order to use that distribution. So I'm just assuming we have a normal distribution. We want the probability that x is between 38 and 98, assuming a normal distribution. So 38 is my lower limit, 98 is my upper limit. My mean is 68. Wow. It's a lot of t, and a standard deviation of 20. So assuming the normal distribution, I get 0.86638, so we'll say 4. All right, let's pause this and do the last one